Gaze up at the sky on a bright day and you'll see it, our brilliant sun, the star at the heart of our solar system. An awe-inspiring sight, isn't it? But what exactly is this radiant ball of light that illuminates our days and guides our calendars? The sun, my friends, is no ordinary star. It's the lifeblood of our solar system, the celestial engine that powers the Earth. It's our planet's ultimate energy source, bathing us in warm, life-giving light and fueling the photosynthesis that allows plants to grow. Its heat, a result of intense nuclear reactions at its core, makes life on Earth possible. Without it, our world would be a dark, frozen wasteland. So the sun is not just a bright spot in our sky. It's our guardian, our sustainer, and our light in the vast cosmic darkness. But there's so much more to this glowing orb than meets the eye. Ever wonder what the sun is made of? It's not just a giant ball of fire. Our sun, the shining beacon at the center of our solar system, is primarily composed of two basic elements, hydrogen and helium. Picture a vast cosmic sea of hydrogen atoms, the simplest and most abundant element in the universe, making up about 3/4 of the sun's mass. The remaining quarter is mostly helium, the second lightest and second most abundant element. Now, the interesting part is how these elements interact. You see, the sun is not just a static sphere of gas. It's a dynamic, living entity, constantly changing and evolving. At the heart of this activity is a process called nuclear fusion. This is where the sun's real power lies. In the sun's core, where temperatures reach 15 million degrees Celsius and pressure is 200 billion times Earth's sea level pressure, conditions are perfect for nuclear fusion to occur. Here, hydrogen atoms are squeezed together under immense pressure and temperature to form helium. This process releases a tremendous amount of energy in the form of light and heat. It's this energy that lights up our skies and warms our planet. Beyond the core, the sun comprises of several layers, each with its own unique characteristics. First, there's the radiative zone, where energy from the core travels outward. The energy here moves in a random zigzag path, taking nearly 1 million years to travel through. Next, we have the convective zone, where energy is transferred by means of convection currents. Picture boiling water, with hot blobs of gas rising and cool ones sinking. That's what's happening here. Then comes the photosphere, the visible surface of the sun that we see. Above that lies the chromosphere, a layer about 3,000 kilometers thick, and finally, the corona, the sun's outermost layer, extending millions of kilometers into space. The sun, then, is not just a ball of fire. It's a veritable powerhouse of nuclear reactions, a constant reminder of the immense energy at work in our universe. Ready for some scorching sun facts that will make your mind sizzle? First, let's talk size. The sun is a colossal celestial body. Imagine this. It's about 109 times the diameter of Earth. If the sun were hollow, you could fit over 1 million Earths inside it. That's a lot of Earths, right? Now let's dive back in time. The sun is a seasoned veteran of the space game, with an estimated age of around 4.6 billion years. To put that into perspective, dinosaurs roamed the Earth only about 65 million years ago. The sun was shining brightly for billions of years before the first dinosaur even took a step. Okay, let's switch gears and talk about distance. The sun, our closest star, is still about 93 million miles away from us. If you were to drive there at 60 miles per hour, it would take you approximately 176 years. But don't pack your bags just yet. Even at the speed of light, it takes about 8 minutes for sunlight to reach Earth. Now here's a fun fact that might spin you out a bit. The sun rotates, just like Earth. But here's the twist. Different parts of the sun rotate at different speeds. Near the sun's equator, the rotation period is about 25 days. But at the poles, it can take up to 35 days. That's right, the sun is literally twisting as it spins. Lastly, let's touch on the sun's power. Every second, the sun emits more energy than humans have used in the last 10,000 years. It's like a gigantic nuclear reactor, fusing about 600 million tons of hydrogen into helium every second. That's a whole lot of power. And just when you thought the sun couldn't get any more interesting. Our sun isn't just a pretty sight in the sky. It has a profound impact on our little blue planet. In fact, the sun is the driving force behind many of the processes and phenomena that make Earth habitable. Let's start with climate and weather. The uneven heating of the Earth's surface by the sun gives rise to our planet's varied climates. Near the equator, the sun's rays are direct and intense, creating hot tropical climates. Near the poles, the sun's rays are indirect and diffuse, leading to cold polar climates. This uneven heating also drives wind patterns and ocean currents, shaping our weather day by day. But the sun's influence doesn't stop there. It also plays a crucial role in the grand theater of life. Plants capture the sun's light in a process known as photosynthesis, turning it into chemical energy. This energy fuels life on Earth, from the smallest microbe to the largest elephant. Without the sun's light, this chain of life would break down. The sun also sends out a continuous stream of charged particles, known as the solar wind. This wind travels at supersonic speeds, reaching Earth in just a few days. Our planet's magnetic field deflects most of these particles, protecting us from harmful radiation. However, some particles sneak in at the poles, colliding with atmospheric gases to create the spectacular northern and southern lights. These auroras are a beautiful reminder of our sun's power and influence. The sun's energy even reaches us in less visible ways. It causes the evaporation of water, driving the water cycle that brings us rain. It warms our oceans, influencing marine life and global weather patterns. It even helps produce our food, as crops harness the sun's energy to grow. Without the sun, life as we know it would be impossible. It's not just a star, it's our star. Here's a burning question. What happens when a star like our sun runs out of fuel? Well, brace yourself for a fiery tale of cosmic proportions. Our sun, a middle-aged star that's been burning bright for roughly 5 billion years, has about the same amount of time left before it exhausts its hydrogen fuel. When this happens, it will begin to expand, turning into a red giant. This isn't just a simple growth spurt. We're talking about an expansion so massive that it could swallow up the inner planets, perhaps even reaching Earth. But the sun's dramatic saga doesn't end there. After shedding its outer layers, it will collapse into a dense core, becoming a white dwarf. This celestial body will shine with a faint glow, slowly cooling over billions of years until it becomes a black dwarf, a silent sentinel in the vast cosmos. In about 5 billion years, our sun will offer a spectacular cosmic show, one last hurrah before it fades into a white dwarf. Our journey through the cosmos doesn't end here. Far from it, we're just getting started. Next time, we'll be leaving the comforting warmth of our sun and venturing into territories far more enigmatic and uncharted. We're going to be exploring the mysterious and captivating world of black holes. These celestial anomalies that warp the very fabric of time and space are as fascinating as they are perplexing. They're the universe's greatest riddles, hiding in plain sight, challenging our understanding of the cosmos. What are black holes? How are they formed? What happens if you fall into one? These are just some of the questions we'll be tackling in our next video. We'll journey to the edge of the known universe and beyond to uncover the secrets of these cosmic giants. Prepare for a voyage into the unknown as we delve into the enigmatic and enthralling realm of black holes. Until then, keep your eyes on the stars.